Okay, it's George Bonk again, and we're going to start putting this whole thing together. And so um, we're going to go over a lot of assembly constraints today, and we're going to go over creating an assembly file, which really is not different from creating all the other files. And we're going to go over actually uploading other kinds of files into your drawings that you can then use. So let's start off with creating the actual assembly file. So if we take a look here, right, I'm in my Shotgun Shell Relitter project, and here's all the parts that we've been doing. I've got duplicates of some stuff. And that's okay. That's great. And actually, I have a parts folder here where I've just taken all the parts necessary and I've tossed them into the parts folder. As sort of a just in case I need something. But for you, you're going to have all the parts we've modeled thus far, and that's really all you need to have. When you take a look at the Blackboard site, you can see I've given you something that looks like the parts list. And there's the parts that we don't have links to, and you should have drawn these. And then the parts that, and I think we actually did the power shot and the power shot measure, so you've already got those. And then there are things like the measure tube or the measuring rod or the pressure tube, things that, or the base plate pad. These are things that we didn't model. Now, instead of you modeling them, what I'm going to allow you to do is I'm going to allow you to actually download a copy of my drawing, and you can use that in the assembly. So I'm going to click on the link to that part, and let's just see how that works. So I'm going to click on the link to that part. It comes up in Fusion in the web browser. So it's sort of a view tool kind of thing. There it is. And there it is. Looks like a little foot. Put a socket cap screw in. And you can go ahead and just take this and download it. Now, the question becomes, download it as what? Becomes the $64,000 question. And I am going to say that probably the thing you will be best to download it as would either be this OBJ format or the Fusion 360 archive. So we're going to play with a couple of these things, and we're going to see how each of these types come in to the modeler, and now we can kind of see the differences. So I'm going to start off with the Fusion 360 archive, and it'll say type your email address, and so I'll say okay, there it is, and it'll say send, and it'll send you a link when it's time. Now, when it says it's being exported to a F3D format, what's cool about that is the native Inventor file format. So that's the same file format that's being done up in the web. And so for you, those are the best kinds because there really isn't a whole lot of translation going from my version to your version, which means you get a very editable part on the other side of it. So I'm going to say okay to this. Okay, and then over here offline, I'm going to kind of bring up Outlook, and I'll show you the email here once it pops up here. I normally don't like to have my email up because it just gets inundated, but here it is. Let's see here. And it should look something akin to this. They won't let me have pictures because somehow they're going to be viruses and take over the world. But it should look something like this. Yeah, there you go. And then you can simply download the file. And so then it should take you to a place where the file then is downloaded, and you can save it anywhere you want. So you can show it in the folder. There it is, my downloads. And I'm going to go ahead and I'm going to take this and I'm going to put it someplace. probably in the folder where I'm keeping the rest of that stuff. So for me, that's going to be 4361. And I'm probably going to make a new folder here. All right, we can call it okay, so I can do that. So I can come up here to my downloads folder. I can go find that file again. Boy, that's gonna be no fun. Sort of back by date. And there it is. And I can then place it in the folder that I want. Okay. Now let's see how this shows up in Fusion. So if I come down here to Fusion, here it is. And now I want to upload that file. And I can simply go find it. There it is. And it should be completed. And if I look somewhere in here, looks like I've got two of them. I've done this before. And this is what, if I open it, this is what I should get. So we notice this is sort of cool because not only if you look down here, not only do I get the sketch, but I get the extrusion, I get the whole feature. So I actually have the features that make up the model. And that's a pretty nifty thing to have. So that archive model gives you probably the most flexibility when it comes to bringing these things in. Okay. Now let's go back to our drawing here. Let's just take a look at another way to do this. Now, mind you, for the purposes of the class, really any of these formats will work, but I think it's useful to see the difference between the two. So I'm going to try the measuring pin next. I can do this. So there's a measuring pin, and I can download this. And this one, we're going to try as a step file. It's really great. They bring this guy in as a step file, just so we can kind of see the difference between these different types. So we'll bring it as a step file. And again, I'll use my Malika-Tarleton-edu. So STP. So if we do that, we'll come back to my and we'll see what we have here. And so we take a look, and that, well, let's see here. I'll show you. Let me show you the email here. There's the email. So there's the email, and it says download file. So I can download the file, and I can do this, and it gives me this measure. Now notice this one doesn't show up with a Fusion looking thing. It just kind of shows up all by itself. So let's take a look at show it in folder. And what I get is something like that. There's my measure pin. I got 2 of them. Okay. Look at the relative size too. See the base pad is about 64K. This is about 4,000 kilobytes. And the reason why is because essentially this is a more efficient use, because what it's providing is providing the modeler instructions on how to build the model, where this is just giving the raw geometry, which always takes up more space. So, but let's see how this comes in. So I'm going to take this, I'm going to copy it, and I'm going to go to my same directory that we went to last time. In there somewhere. There it is. There's the shotgun shell. I'm going to paste it. So I'm going to come back to mine. I'm going to get rid of this. I'll get rid of this. Get rid of that. And I will come here and I will upload that file. And notice it's going to do its thing now. It should upload. So you can see it here. It's coming in and looks to me like this is the original. There's the copy. So I'm going to open this guy. We can kind of see what the differences are here. So there is the pin. And notice we get all the features. So we should get the actual screw threads and we get the actual knurl. So if we can see here, if we take a look at this, there's no tree down here that tells us the individual features. If we look at the bodies, we still see that there's only a single body, but that's it. But there are no sketches and there are no features built in the sketches. So when you think about it, right, the archive version gives you an editable model. This thing will give you a model, but the model's not editable, really. Now, obviously, you can do things to it. So if I wanted to drill a hole or cut a slot, it would do that to the model, and obviously, we would see those changes down here. But in terms of being able to easily come in and change the pitch of the threads or whatever by changing the feature, not so much. And Inventor kind of tells you this by looking at, the actual model menu up here. It kind of throws you into what's called a sculpt menu, because really none of this is parametric to work with. So that is sort of the differences between the step file and the Fusion file. So that's one thing. So okay, so I'm going to save this. We're going to try one more just for funsies. I'm going to try bring this up over here. And we can do the measure tube. And the one we're going to try here is we're going to try an Inventor. Just so you can kind of see so this is a polycarbonate tube, so it has a material applied to it. So I can download this thing. Obviously, we tried this archive. We tried STEP. And by the way, STEP is probably, if you're going to find different parts from different manufacturers you're trying to pull into your model, the most universally acceptable file format, STEP. Everybody takes it. So you know, if they give you a choice of what to pick, you know, step works. We're going to try an Inventor 2016 model just so you can kind of see the compatibility between Inventor 2016. If you model something of that and then you try to bring it into Fusion, what do you get? So there we go, and I can, again, type my email. And give it just a sec to show up here. So there's my, I'll download the file there. And there it is as a, so I can so there it is. And I will cut and paste it into that parts folder. And there is the measure tube. So let's see how this one does. We'll take this away. We'll take this away. Take my email away. So I want to upload. And I can find that measure tube. And I can upload it. And we can see how that works as that comes in. Yep. So I can close that and kind of scroll down here. Scroll up here if I can't find that measure tube. So it looks like that's the measure tube right here. And we can open that. And as it does, it should convert it and notice when it comes in, notice when it comes in, no tree data, which I find amazing that you'd think Autodesk products would work better this way, but really it doesn't. So there's no real advantage in trying to bring things in as an Inventor file versus a step file. You get about the same thing. There's no tree data, there's no sketch data, there's nothing. So, you know, it's not as cool as it should be. And I don't know whether that's just because they don't want to see Fusion models and Inventor models being used interchangeably because they're afraid of their market share. Who knows? But they really have lobotomized sort of this part of it. So unfortunately. Anyway, okay. So we'll do that. So we're going to assume that we have most of the actual drawings. And if you don't have the drawings, I think we've kind of gone through pretty much how you're going to get the drawings. The other thing we have not covered, I just want to give you a setup, is we haven't talked about how to get these sort of purchased parts, and we'll get to that, just not quite right now. Okay, so stand by, that's coming. All right, so here's the measure tube, the base plate. And so what I'm going to do is I'm going to take a look here at a drawing that sort of has all, if you take a look at this, sort of has all the parts and pieces laid out here. And I'm going to first put things together, and I'm not going to use any of the fasteners yet. So I'm basically going to put things together where I'm using hole locations and center points to put the parts together. And then I can come back and I can put my fasteners in. But at this point, I'm just trying to get the parts to actually align. That's what I'm after right now. Okay. So I'm gonna be looking at this, and this is obviously, we have that online for you. Okay. So I'm going to start just a new design. Not a new assembly, just a new design. And looking at it here, there's a couple of different parts I'm going to put together. So I'm going to put this piece here, and these rods that go through. So I'm going to put those together along with this piece, and I can kind of get the beginnings of the part. So let's see how that works. So obviously I can look here, and here's the base, there's the base, there's the base plate. I'm simply going to insert this into current drawing. Oh, looks like I gotta save it. I'm gonna call this main assembly. Then I'm going to insert this into current design. Okay. Now notice how we've got this thing on X and Y. And I'm just going to say that's okay, because I'm going to turn this. And so, looks like that's how I have this thing turned. Z's pointing up. And that's working for me. Okay. Now notice how this here, right, has the bodies and the sketches attached to it. But what I'm going to do with this piece right here, and this is sort of important when you're assembling things, is I'm going to take this piece, and this piece I'm going to ground. That way when things assemble, they're going to assemble to this, and this thing can't move. So I'm going to basically take this piece right here, and I can highlight it up here, and I can use a thing called ground. So grounding basically puts a pin in this piece and says this piece cannot move. And it makes the assembly process easier because the modeler then has one known that this thing doesn't move. And so then it can figure out how it translates the parts to it, which makes assembly a little easier. So then we're going to put the base in. So I can get my base here, and I can insert that into the current design. It should pop in there. Gotta turn my mail off, that's killing me. Okay. So there's my base. All right. Now, my base, all right, I need to start assembling these two pieces together. And oh, by the way, there's a flaw, and we'll get to it. So we'll have to go back in and actually modify one of these drawings, but I'll show you where that is. So I have to put this in here. I'm going to have to line these two things up on these holes. So it's a little more complicated than it was in Inventor. So let me show you how this works. These are going to be joint assembly constraints. So notice if what I want to do is I have a couple of different rigid, revolute, slider, cylindrical, pin style ball. Rigid is really going to be my go-to assembly if I know that these parts are not going to move relative to each other. That is my go-to. Okay. The rest of these also are implying a a degree of motion. And if I know ultimately these two things are going to bolt together and there won't be any motion, then what I'm looking for is a rigid constraint. So that's going to be the one you're going to see the most. So I'm going to pick. Notice how I'm going to pick that and that, and then I can flip it. Now notice, even though I have that, even though I only have one constraint, that thing isn't moving. So those two now are constrained. Okay. So then I have these two bars. Yep, the lineup bars. So I'm going to insert that into the new drawing. And I can move it by simply taking this. I can create a copy. Well, maybe I can. I don't know. We'll find out here. No, maybe not. I'm going to insert that again. And notice it gives me that move, so I can move them. And there I go. Okay. So let's make sure I can assemble these guys. So I'm going to then assemble. I'm going to go back to my rigid constraint. I can pick that center to that center. And I can flip it. I can do the same thing here. Obviously, I can flip that. So I have something that looks like that now. Okay. All right. Now I'm going to have this base here. This base here sliding up and down on these posts. And I'll have this top plate here assembled. But not yet. So let's work on that. So let's go find the head of this thing. There it is. I'm going to insert that. Now this one's going to be a little bit different because the head's going to actually have to move up and down. So I can't just do a rigid constraint on the head. Let's see how this works. I can use my controls to sort of move it around. But ultimately, there it is. So let's look at my assembly constraints. So now my constraints now are pin slot, planar, cylindrical is kind of what I'm looking for. So I want to have the center line of this and the center line of that be together. So I'm going to try a cylindrical constraint. And I can pick that and I can pick this. Let's try that again. There you go. So I'm picking that 2D shape. There we go, and I can do that. And obviously now we have something where it can zoom up and it can slide up and down. It also can move. So again, I can come back here and I can put. So notice as I move things, it wants to bring it back to that same location, right? So when I go to assemble, it wants to bring it back to here. Now, there's another option that I have, and that is if I free-formally move these things around and I want to capture where that position is before I take the next constraint, I can do that, and it's really called capturing the position. So if I want with a part like this, I want to stay like that, not snap back into where it was before. Up here under capture position, I can do that. If you notice down underneath the tree, it gives you a position capture. And all that position capture is saying is that this thing's moved from where it was to where it is, and it captures that delta. Now when I go to create my joint, then I can say, okay, a cylindrical constraint, I can pick this. Actually, I can pick this cylindrical constraint, and I can pick this. Okay. And now this thing slides up and down. So away we go. So far, so good. Okay. Okay, so let's talk about the next thing, which is that top plate. And we'll put that on. This top plate here is me signified by this plate right here. So where's the top plate? We can find it here. Okay. And again, here, if I want to, I can capture that position of where this thing is. Now, here, these guys are going to be located on these two pins. So again, I'm going to assemble, and I can catch the rigid. Okay, so we can see that. Now the problem is, that's a rigid constraint, and so what's going to happen when I try to constrain this one, and I think you can see what's about to happen. So here's my rigid constraint. There. Notice how it doesn't work. So notice these two constraints on here, this one has a problem. I'm going to come down and just delete both of them. And I'm going to delete those constraints. And let's just think about this differently now. So really, we want to have this thing flip around. And so what I want to have for this one is, if I make this one a revolute joint, see how that works. like this. All right, so let's see here. This we can do with a rigid joint. And I'm going to pick this here. And I can pick this here. Well, let's see here. Well, that didn't quite go. All right, let's try that one more time. So we're going to try to assemble these things, and we'll assemble them with a cylindrical and this one we will put in a rigid joint. So notice these things move up and down. These things I'll put in a rigid joint, so I'll put in here. There we go. And those two are put together. So I have something like this now. Okay. And then I think we have something like the measure cup that goes on this thing. Let's go find it real fast. I can assemble this with a cylindrical joint. And we can then assemble another one where I'm going to let's see here. So this one. Okay, let's see if we can't make this one go. So I'm going to try and position them where they're relatively close to each other, and then I'm going to try and do this. All right, so then I'm going to go, again, rigid joint. All right, let's see if we can't try that one more time. So I want to try and put this hole put this hole right there. So let's try that. So we're going to do a assemble. There we go. Ah, and that's my problem. Okay. Yep. Let's assemble. All right, one more time. And I'm going to all right, let's see here. So I'm going to try and get with a rigid joint. I'm going to try and get that and that. So we're going to try this again. So there to there. There we go. And those two are now set. So that one has a revolute joint and that one after a fashion, but you really have to kind of line it up. Got to be a fixed joint, and there I go. Okay. Well, looks like that's still being a pill. All right, let's do this. I'm going to delete the joint. And I'm going to do another assembly here. I'm going to do another assembly here. Okay. I'm going to save this. And away I, well, still, no, still. So we can assemble. I still think ridge is my best bet. Well, I'll tell you what, let's delete all of these joints. Let's try it one more time. And if not, we'll do it with something else. All right. So let's see here. Let's first start with an assembly, and we'll do a cylindrical between that and that. All right. So then we're going to assemble again. I'm going to assemble this time a rigid joint. And then there. Okay, we're going to have to pause and come back to that. Give me just a sec. Okay, folks, I'm back, and yes, I'm wearing a different shirt because it's a different day. So the problem I was having, and you watched me kind of fumble around with it, was that when I put the part together, I had a difference between where these two holes were and where these two holes were. So that was kind of weird. So I went back and tweaked my parts, and now they're all the same location. And I think that was my error. However, when we install this thing, and this is a flaw that I'm seeing. When we install this thing, it doesn't seem to want to go between this hole and this hole, and I'm not too sure why that is. To be quite honest with you, because they're the right size, but it seems to, it doesn't want to find that they are the right distance apart. So I've checked, and they are, but something's going on. So, but it doesn't mean we can't assemble the project. So let me show you how this goes together. So the first thing we want to do is you want to use a cylindrical joint, and the cylindrical joint then will be between this cylinder here and that cylinder there. And then we're going to say okay to that. So then that's set just like that. And then the next joint we want to create, and I'm going to capture this position because I want to make sure that it sits right here, is going to be a rigid joint. We're going to try a rigid joint. We're going to see how that works. Between here and there. and that should, and now I don't have any errors, and that should locate my part. And if we look, see, that's lined up, that's lined up. So I'm not too sure what the hang-up is, but there does seem to be a hang-up, so there we go. Okay. So next object that we're going to bring in is going to be the measure bar, and I'm going to import this. And the measure bar is going to allow us to use a new kind of constraint. There it is. And I'm just going to move it and get it sort of close to where it needs to go. So we notice where this threaded hole is here. It's on either side, right? So what I'm going to do is I'm going to use an assembly constraint. This time it's going to use a planar. I believe so, planar assembly constraint. So I'm going to pick this surface here, with this surface here. And so notice how that now is sitting on that surface. And so as we take the thing, we can slide it. It'll slide anywhere on that surface, but it'll sit on that surface. Yep. So we can kind of drag this guy back. And we can drag them back this way. And have something like this. Okay. So the other constraint I'm going to want to use then is, again, I will go back to my joint constraint, and I'm going to capture this position to make sure it sits there. And I'm going to go back to my planar, and I'm going to have that surface with that surface. Let's see here. There we go. Let's try that again. So I will do, again, capture the position. All right, let's try that one more time. Planar. We'll try a slider this time. Let's see if a slider goes. So let's see here. So we'll try a slider, and we'll try a slider joint between here and this back. No, that didn't work. Let's ditch that. All right, let's see here. So what do I have? Looks to me like I have one planar joint, and I should have, and I want to do another planar joint. So let's do one more planar joint. Here we go. do a planar joint. So I should have something that where this thing slides back and forth now. And just in case you didn't see that, let me do that again let me do that again slower, because that wasn't exactly obvious. So when I put that joint on, instead of picking the face, because this thing likes points, so this is what I'm doing. I'm going to capture this position. So when I put this planar joint on, instead of picking the face, I'm going to make sure that I get this face, that surface there. And I want to make sure that I pick that as a planar joint when I do. And then I can come in here for the second, and I can pick this center of that hole. And those 2 points then are the points that it's going to, there you go, meet as planar. Okay. So I can do that. And then, just so we can so we're going to insert, got the wrong measure stud here. Hang on, let me get the right one. I'm going to get that measure stud. There we go. And then I can give it an assembly constraint. And this one, and this gets a little bit weird. Capture that position. I can grab that point and see on these modeled threads, getting the actual point is really difficult. So I'm going to try and look right down the barrel of this thing and see if I can't get that center point. I can't quite get that point. So that's kind of a problem. So when you can't do that, then probably your best bet then is to try to construct a point. And you can try to construct a point a couple of different ways. You can try to pick a vertex, and that's probably not going to work all that well for me. Or you can try to pick, let's see here. let's see here. All right, there it is. And so I can create that, and then I can also construct. I should be able to and I can construct a point there. Now let's see here. Hang on. Let's back up. Okay. So I need to have a little helper object here. And to do this, I'm going to first have to edit this part. Let's try that. So now I'm editing, should be editing this part. And I can open it. And we'll just do that. And I can go ahead and put that, I can go ahead and put those features on here. So I can pick this. There's the center, or there's that axis. And then I can do, and there's that point. So I should be able to save this now. And update my part. And there's my point and my axis I'm looking for. The reason why this didn't work is that I was doing this on the assembly level, not the part level, so I got a little confused there. So now I've got this point sitting right here, which is kind of handy. And now if I want, I can simply assemble, and I can do a rigid assembly between that point and that point. Well, that didn't really work all that well. Let's try that again, shall we? So I can do an assembly between well, let's see here. Well, looks like I'm gonna have to, yeah. Boy, it's just a pain. And a lot of this has to do with this cylindrical with the modeled. So I'm holding down over this point to get my selection set up here, and I'm just looking to see if any one of these faces gives me what I'm looking for, which is a hole that is me out here. And just not so much. So I wonder if you could do a ball, perhaps. That at least gets the thing to where it is. That's a point constraint. Not too sure that's helpful. Yeah, I'm not doing that. Well, let's see here. Okay. So let's see if we can't try one more trick here. I believe try to pick that cylindrical joint or that revolute joint. See if I can't get that to work, and not so much. So you can do a rigid joint, then we'll just have to modify the angle, looks to me like. That's about the only thing we can do. It's at 90 degrees. Well, let's see here. What exactly the 90 degrees I was looking for? So that's turning it that way. Yeah, that's 90 degrees in the wrong plane. see here. No. Well, not exactly what I'm looking for. We'll try revolute on the x-axis. This is really hard. Okay. Alright, guys. I think we've suffered enough with this. So let's back up. I think the easiest way to do it, I will admit defeat. The easiest way to do it is to open this thing up. So we're going to open up the measure bar, just like we did before. And we're going to take a look at this hole here. And we're going to tell it not to model the threads. They'll be schematically cut threads. It's the best I can do. So I save this. Update my part. Delete my axis that now is unnecessary. Okay, so now to put this in together, it should be nothing more than a rigid joint between here and there. And we can look and see that that flange is intersecting that. So we can move this guy out just a little bit. A little more realistic there, something like that. There we go. So obviously as we screw this thing in, this surface here will hit that. And that will give us a... And one of the nice things you can do, we can actually turn on if we click the outside body here. And we can click this body here. We can do something called context sets. And we can actually do a context set between that body and that body. And the reason why the context set's useful is because now that that's set, as this thing moves back and forth, what you can see is when it gets to the end here, it stops. So it won't allow you to move past where it hits that other body. Now that takes a lot of CPU time to do that. So when you're assembling things, you don't want to do that. But now you can actually mimic what that mechanism would look like here. And that's what context sets do. All right. I'm going to turn my context sets off. And when I do that, obviously, there we go. Sorry for the buzzsaw noise out there. And away we go. So that should be done. All right. So this object slides up and down. Looks like I've got an extra one of these things down here somewhere. Probably can delete that. Yeah, that one I can delete. Okay. All right. So a couple more things, and then I'm gonna kind of pause, and then you guys can keep on chugging. So obviously the measure tubes. So the measure tube should be nothing more than a rigid constraint. And obviously you want to grab that arc and that arc and flip it. Whoops. Well, looks like you grabbed the wrong side here. Yep, see, notice this has a smaller, that has a larger one. So yeah, so assemble, and that's going to be a rigid position in there. To there. Oh no, wait, hang on. Let's try that one more time. No, it's going to be there to there. There we go. Yep. And same thing down here. There's the smaller offset, there's a larger offset, so here we're going to go from there to and you should have that. Okay. Okay. Now notice right now you see all these little symbols. This tells you what type of joint is sitting at what connection. And to edit them, you can simply select them and, you know, deal with that. If you want to turn the joints off to get a cleaner look at your model, then you can just turn the joint off and you get to model won't show that anymore. Okay. All right, I'm going to take a pause here and I'm going to assemble the rest of this. And then when I come back, then we're going to assemble the handle, and that should be it for the. And then we'll show you how to do the actual fasteners. And we'll show you how to do that. So more to come, but I think to move the movie along, I'm not going to assemble the whole thing for you. You can do some of that yourself. I'm just going to kind of keep on chugging here. You should have everything you need to do that. So I will be back momentarily. Okay, so we're back, and I've done a lot of assembling on the part here, as you can see, but I want to kind of stop and demonstrate one of the pieces that we're going to have to deal with, and that's going to be this linkage here. And so I want to kind of step you through how that's going to work. So step one for the linkage is this subassembly here, this handlebar assembly, and for that I'm going to use an assembly joint, and I'm going to use a revolute joint so it can revolve. I'm going to start with that point there, and I will have a common point here. So I'll have something like that. And so that's going to be crucial, right? So that one's set. Then I'm going to then use another revolute joint here, and I'm going to pick that revolute joint and that one there. Okay. And then finally, I'm going to have, again, another revolute joint, but I'm going to try this, and I'm going to try that. Oh, it looks like that's going to be an issue. So let's see about that here. So okay. And there is my so I'm going to delete that joint, and I'm going to just do a little test here. So this here can move up and down. So this is driving this whole thing up and down. So I'm going to try and ground the head here. I'm going to start that. And I should have something like this. And I should have something like this. So let's see how that that got a little weird. Let's see how that works. All right. So I'll try that assembly. Again. This time we're going to use what's called a cylindrical joint, and we'll try that. So I'll try that, and I'll try this right here. And that seemed to do the trick. So now I'm going to unground this head. And now you can see we have sort of the action that we're looking for there. So now on the other side, I'm going to take this same clip here, and I'm going to do my assembly here. I'm going to capture my position. And I can do my assembly here where I do my revolute joint between here and here. Probably want to flip that. There we go. And then obviously we'd want to do a cylindrical joint there and obviously there. And that gives me a well, let's see here. Hang on. May have thrown an error on that one. So it's component priority. Let's see if we can't back up one here. All right, so there is the, there we go. And obviously we're gonna try that one more time. So there's my joint, cylindrical joint there to there. And looks like that joint didn't fly. Delete that. Well, let's try Revolute joint. The Revolute joint should work. Now let's try this. So instead of having both of those go there, I'm going to try a Revolute joint where it is a cylindrical joint between here let's see, we want to pick components. Well, let's delete that. Let's delete that last one. And I'm just going to take this, the handle assembly, and I'm going to ground it just for the time being, only because I think that way it can't move. And then I'll try to put together this next part. So I'm going to try this thing again. Now it's going to be a cylindrical constraint, and it'll go between there, and there. And obviously grounding that probably didn't do much for me. So let's back up. And let's ground the head then. All right, let's see if we can't put this in together. So again, cylindrical between here and there, and that causes a problem. So that didn't work. All right, so then we're going to try this. So we'll do a cylindrical between here and we'll see what that does. That should give us a warning. That should give us a problem. So then a revolute between there and there. Okay, well, it looks to me like they should be the same. So I'm going to unground that. And then let's do so there is There is and our under joints. There's a revolute joint right there. And we can set some joint limits on this, where the maximum is going to be 0, or the minimum is going to be 0. All right. Okay, so here we go. I got it. So this is what we do. So we're gonna take the 2 links here, right? And we're going to give them revolute joints. Capturing their positions. I'm gonna give them revolute joints here and there. And that ought to work just fine. Come over here, I can give this next one revolute joint. There. To there. So life is good. So there we go. So now what I'm going to do between these two to keep them together is I'm going to give them a cylindrical joint. And so that way these things are going to kind of move as one. And so now when these things move, they'll move as one entity. So then take my handle here, and I'll give it a revolute joint. All right. So the difference between, the revolute joint and the cylindrical joint is the revolute joint simply goes in a circle. The cylindrical can go in a circle and back and forth on an axis. So I'm going to give these guys a revolute joint here. And I'll give it to them there. So then finally, kind of move this guy. Give him something right there. And then I'm going to give these two a cylindrical joint. And the reason is that these two pieces are a little bit, they're not quite on the same plane. So I'm going to pick here. And I'm going to pick there. Well, okay, maybe not. Let's see how that one works. So I'm going to try this. I'm going to try it, and again, capture the position. And I want to try a cylindrical joint. And I'm going to pick that cylinder, and I'm going to pick that cylinder. And away I go. And that should be that. So now as this moves up and down, right, you can have that action. Okay, so last thing here is there's a support that sits in between these two. I think that is just itching for a, that's just itching for a fixed constraint or a rigid between there and wait for it there. You can flip that thing over and away we go. So we got that. Okay. So that being said, we're almost done. So we're really to a point now our pads on here. And we can paste one. So these little pads, you notice that they've got a space for a, so you can take a, these are prime for rigid joints. Again, you can go this against that. And again, let's see, we can do these rigid joints, this against that. Okay. So let's talk about a putting together a bolted fastener, right? So obviously here with these guys, right, if I do a, that gives me a diameter of 1/4 inch, so a 1/4 inch bolt should be going through that. So if I want to put together a fastener, and we'll say that I probably need to have something so maybe a 2-inch socketed cap screw with some washers. So to put together the bolted fasteners, we can use fasteners from McMaster-Carr. And so let me show you how that works. If you click on this, it will load McMaster-Carr, and you can actually insert those components. Try that again. There we go. So there's McMaster-Carr. Took it a while to get going, but screws and bolts, socketed hexagon cap screws. There we go. We can say and we can just go with alloy steel socketed cap screws. Now over here you can pick what size you want. So there's my 1/4 20. And then I can go for the length, and I can do, I think I said 2-inch. And I'll go with partially threaded. And we can download this thing as a step file. And notice it puts it right into our model. So we're going to kind of move him over here. Now, one more thing I'm missing is I want to have some washers, and I want to have a lock nut on either side. So let's put those in. So McMaster car, yet again, there's a washer, flat washer, general purpose flat washer. I can tell that I want to be a 1/4 inch flat washer, and away I go. I can find my so there's that. Probably need to copy and paste that. There we go, there we go, there we go. So there are my 2 washers. So the easiest thing to do to put these things together, I find, are rigid constraints. So we can capture the position, and I can basically put the washer there, flip it. It's on the outside, good. I can do the same thing here. And then the bolt, can simply assemble, I think, with a rigid constraint from there to there. There you go. And I want to make one more thing here, so I want to insert a McMaster car part, and we want to have a nut, and I want it to be a lock nut. And those are 1/4 20, grade 8. And then you can again assemble and there we go. So that does a, and obviously for these guys down here, right, we'd have to look at the so 1/2 inch. So if I did something down here, went to 3/16. Sounds like a number 10. So we can make these where we have there to there to there. So that's the assembly process, and obviously there's work to do, but probably not that much terrible work. Your job is going to be to put all the fasteners here, fasteners that are missing up there, right? Obviously they make something for this one. This is a that's the measure pin. So they make something for that as that comes in, yes. That can kind of come up. And that can there you go. So there are bolts, there are screws here that you have to put in. Screws here you have to put in. Screws here that you have to put in. Right. Your job is to come up with what those bolts need to be and insert them. So that's the assembly. When we come back, I'll have this thing fully assembled and we'll talk about doing photorealistic rendering. But I think your challenge right now is to try and put the thing together. Remember, if you're having problems with the constraints, try different combinations of constraints, try different constraints, right? So combinations of constraints are the things you really work with. Remember that, you should be able to do this whole thing with rigid, revolute, cylindrical, and planar. That really should do just about everything you want it to do. Okay? All right. So I hope you put your shotgun shell loader together better than I did. Don't worry if it took you a while. I would do this in a couple of sittings. Happy AutoCADing, or happy fusioning. Good luck. Bye.